happy to report إنه Professor Tariq Khalil, the president of the university, is with us, and Professor Tariq is a very well-known management of technology professor. He is for Gautam. He is got many positions in the higher education system in the U.S. Last one in Florida International as Dean of Graduate Studies, and he has played many roles as well. And he is the one responsible. He is the one responsible for establishing Nile University. I'm very happy to give him the floor to welcome the people here, since probably this is his last lecture as a president. He's going to stay with us in the board. He's going to stay with us as management of technology professor, but he is really the one who was behind the scene, the unknown soldier in establishing technological and entrepreneurial university in Egypt. Dr. Tariq, please, the floor is yours.
Thank you, Hassan, and good evening, everybody, and welcome, Professor Tshakaporti. We are delighted to have you with us. Indeed, tonight we have a very important lecture that is given by one of the real experts in this field. Business analytics and data sciences are extremely important subject for the business schools and for all schools, actually, as far as I'm concerned. And we are delighted that our business school is taking a lead in this area and starting its program, MBA program, with some emphasis on data analytics and business analytics and so on. And we are very proud of our university. We are very proud of our School of Business. And Dr. Hassan has done an outstanding job in actually bringing the latest in the areas of business and economics and finance and related subjects. So I'm very excited about the future here for the school and for everybody that's connected with it. Certainly at the University of Miami, we pride ourselves of being on the forefront of technology. And we have started many years ago into big data analytics and Internet of Things and all the technologies that are very pertinent today. So tonight's lecture is a good introduction into our new program in the business school, and we are delighted to have such a great expert as Professor Gautam Tshakaporti with us, and I welcome him and wish all the attendees a very wonderful lecture and a fruitful discussion. Dr. Hassan, please, it's all yours, so we can go ahead and get started without any further delay.
Great, thank you so much, everybody. This is my privilege to introduce my good friend, Gautam Tshakaporti. I know Gautam for over 25 years now. We go a long way, and he has been always a distinguished professor. He is the director of the Data Science and Data Analytics Center at Oklahoma State. He has been given many awards. I think we have already put his bio on the announcement. He has been very instrumental with the SAS Institute, so he is a SAS professor. And I can tell without any hesitation that if you want to know data analytics, and if you are not familiar with data mining, this is the fellow that you should really ask for. Professor Tshakaporti is going to teach 2 courses for us in the MBA on data and business analytics. And we are very happy for him to start whetting our appetite by giving us this lecture. Gautam, the floor is yours.
Thank you. Can you hear me?
Yes, very well.
Thank you very much. And I'm honored to be invited for doing this. And it is my pleasure for being here. Good evening to everyone. And I'll try and make this interesting because sometimes lectures like this could be very, very boring. So I'll give you a little bit of my background. And before you start wondering, Dr. Hassan has already given some background. Why am I giving you my background? There is a reason for it. The reason is, and this is a message that I take to every corner of the world. And believe me, I travel to pretty much every corner of the world, which is it doesn't really matter where you start. It doesn't really matter what your background is. At the end of the day, what matters is what you have inside here and here. And as long as you have intellectual curiosity, and as long as you value education, the world is yours, my friend. That's why I'll give you my background. Because if you ask me today, 20 years ago, 30 years ago, 40 years ago, is this what I would have been doing? No, I had no idea. Absolutely no idea. If you think I was born into richness, no. I'm a product of a refugee colony. Yes, my friend, I didn't have electricity until the 8th grade. So my message is this, okay? Education is the pathway to success. There is no other better lesson I can provide. And I take that lesson to everywhere in the world. So with that, let's get started. I will go through a very high level overview, not digging into details. Details can only be done in a classroom, okay? So my goal is to get you a sense of what is going on and in the world of analytics. And if you're new to the world of analytics, it will set the stage for where we are, how we got there, what are some of the challenges involved, and what do we need to do as universities, as industry, to get the most out of what we have today. So, and then I will end this with a case study or two, depending on time. And one case study I want to address is the one on financial industry. I understand many of you might have some interest in that area. So that's where we'll go ahead and get started. So again, from a background point of view, I was an engineer before I became a marketer. If you look at my degrees, I was a mechanical engineer, worked for a couple of years. Then I went into an MBA program and did my MBA and became a marketer, worked as a marketer for a while. And then that ping of intellectual curiosity, I'm not satisfied. And again, that's the message I want every one of you to take it to your kids, your grandkids, your friends, everybody else, that what you need is the value of education. So I left India to come to US, did my PhD in business and a master's in statistics. Again, I could not have chartered a better path for what is needed today for me to do the work that I do today. What I do today is a combination of multiple different things, and I'll take you through that in just a second. But basically, I run the data analytics program at Oklahoma State. I teach in that program. I do some consulting from time to time, or I sometimes go around the world giving talks. So thank you for inviting me. Those are my very brief background. Now, in the world we live in today, I said I'll try and make this interesting. So I did something yesterday. I went in Google and searched for these terms, okay? And if you look at my highlight here, you will see that I searched the terms worldwide and jobs and education and past 5 years, okay? And and this is for the last 5 years, and it is current until yesterday. Maybe the numbers have changed a little bit today. That's the world we live in. Things change. What you will notice is that these 3 lines, people get confused. What is analytics? What is data science? What is AI? Numbers don't lie. It's how you interpret the numbers. That's where the problem is. If you look at them, the way to look at numbers, and if there's one thing, again, I want you to take from me is this. I look at numbers all day. I don't look at raw numbers. I look at trends. Trends. Look at the trend and look at how they closely mirror each other. What that means, in my view of the world, is that those are all the same thing. We come up with different names. So I know it's 7 o'clock in where you are, and you may be, this may not be the picture you want to see, but I'll show you that. I don't know if you like fish. This is a great fish, by the way. But
Professor Gautam, can you share the screen?
Yeah, Gautam, we haven't shared the screen yet.
Oh my gosh.
That's okay.
Because hang on.
Well, you took it off when Mustafa was trying to do the interpretation thing.
Darn it. Sorry. Okay, now you see the fish. Now you see the fish. There is a story for this fish.
Okay.
Okay.
This is the baraya.
Looks that way, right? It looks that way. It's actually Patagonian toothfish. Patagonian toothfish. Now, if I tell you that name, would you go and order it? Patagonian toothfish? No, none of us will order a fish steak while we're up at a restaurant looking for a nice meal. Patagonian toothfish? Oh my gosh, no. But what happens if I tell you this is Chilean bass? You're going to spend money. You're going to spend good money to pay for Chilean bass. It is the same thing, my friends. It's no different. No different. They're the same. What's my point? My point is you will hear, if you are in the world of analytics and if you're listening to popular press, you will hear all kinds of terms, all kinds of terms. They're all different way to frame the issue because we can't sell Patagonian toothfish. We will sell it as Chilean bass. So keep that in mind. Keep that in mind. What's my point? My point is the core things in analytics, call it whatever name you want to call it by, but call it analytics, call it business analytics, call it data science, call it artificial intelligence, call it blah, 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 blah. Fundamentals don't change, my friend. If you get fundamentals right, everything else is just context, which is different, examples, which is different, the way it's applied, which is different. So what's the fundamentals? All right. So my point on this is, again, I know some of you come with different backgrounds, so I'll tell you my view of this world, okay? And then I'll give you a definition. But let me first make sure people understand that it is not information technology. It's not IT. Analytics is not IT. Analytics is not information science, computer science. Analytics is not programming and coding. Analytics is not visualization, dashboarding, business intelligence. It's not statistics, models, or machine learning. It's not optimization. It uses all of them. Analytics, at its core, uses every part of this: IT, computer science, programming, coding, visualization, dashboarding, statistics, models, optimization. Every part of that is used as analytics. So what is it? Here is a definition of analytics. It's a scientific process. Notice that I have put this in italics because I want you to understand this. Analytics is not done in a haphazard fashion. It is a scientific process. For transforming data into insights, data is raw. The stories we tell with the data are the insights. At the end of the day, if you don't learn to tell stories with data, people don't get it. People don't get it. And it's important to generate those insights. And then generating those insights makes no sense unless somebody uses it for making better business decisions. A very simple definition of analytics. I have taken students who came with many different backgrounds, some with engineering, some with IT, some with marketing, some with fine arts, some with no idea of coding. But if you have the intellectual curiosity, if you are willing to learn, and if you're willing to learn with help, you could be an analytics professional. That's what I want to put the message to you. Now, let's talk about, what, and I like this. This is a slide from a professor, Davenport, and he's very, very well known. Okay, and it's a nice way to think about it. And I've given you the reference for this book. It's called Competing on Analytics, and I'm using this from this book. And Professor Davenport talks about, we have in an industry, we have two sources of competitive advantage. Two different things that we need to do. One is to gain competitive advantage, and the second, we need to create degree of intelligence from data. So most industries start with at the very bottom end of the scale, which is the raw data and the clean data. When you are in this part of the world as visualized by these two axes, you don't have much competitive advantage, neither do you have much of intelligence, but it's needed. Without this, nothing else can be done. Then companies move up this line by creating what we call standard reporting, answering questions such as what happened, ad hoc reporting, how many, how often were, query drill down using databases, and alerts, what actions are needed. This is, as we move up this arrowhead, what you will see is the competitive advantage increases and the degree of intelligence also increases. Following this comes what is called more modeling, statistical analysis, forecasting, predicting, but you can't really do this until you have gone through this. So this bottom part is called descriptive analytics. Then when we go into this prediction, what will happen next? Why is this happening? These are the kind of questions that comes under what we call predictive analytics. And then at the very end of the scale is what we call prescriptive analytics. And what is prescriptive analytics is not just what's going to happen, but can I put things together in my business in such a way that I can get the best possible result. We're not predicting, we are changing. We are changing our internal mechanism, our external facing sites, our resource allocation, so we can get the maximum value for the company. That's prescriptive analytics. So if you don't learn anything today, at least take this with you. Those are the three core analytics things that we talk about in any analytics program. Now, as I told you that I would give you a sense of how analytics has evolved over time, and at the same time, I will show you how we in the universities are evolving over time to match this. So this is again another very favorite author of mine, Bill Smarjo, a good friend of mine. Both Tom Davenport and Bill Smarjo are very good friends. And he wrote a book called A Big Data MBA, and I've given you the reference here, and this is taken from his book. And what he talks about is at the beginning, where most organizations are, and this is where most US organizations were until about a few years ago, okay? This is where they were. What they were doing was basically monitoring the health of the business monitoring the health of the business. They're generating insights and trying to do some optimization of processes within the business. That's where they were. And this is where the domain of descriptive and predictive analytics were. But what's happening today in the world of business, as at least in the US world, is that we are now moving from what we call focusing internally to make our processes more efficient, making our marketing, accounting, finance more efficient, to something else. we are moving to what we call monetization, external customer monetization. Every business today is looking for a way to make more money, honey. It is true. Now, what if you're a nonprofit? It's okay. If you're a nonprofit, then you are also trying to generate money. You're trying to create other value. But in the world of for-profit business, today, the emphasis is, at least in US, that we have already done this. Most of us have already done this. We are doing our best to create insights and create products and models that can generate new value for the company, be it in a new market, be it opening up a new segment, be it creating a new service. But the focus has shifted from just being internally more efficient to externally monetizing what we have, taking it to the market and doing it in real time. One of the big changes that has happened is today we have the capabilities to push product and services out, at least in the world of digital world, very, very quickly. What we call it is we are in a perpetual beta. You know, the beta is the beta testing. When companies go through different kind of testing, they do alpha testing, beta testing. In the world we live in today, we call it, we are in perpetual beta. We are constantly testing. We're constantly, and for that, and we're testing it with data. What's the point to this? The point to this is nothing is steady state. Everything is changing and companies are, and it's not just because of COVID. This has started 3 or 4 years ago, this journey. Now, to make this clear, you know, with respect to application of analytics, where we started and where we are today, basically all of the analytics application primarily started in the world of marketing and finance. Why? Well, because of a couple of different things. One is, we have data. We have control over the data. And we have data, we have access to the data, and we can use this data. So finance started this by a long time ago, looking at risk prediction and risk management. And marketing have been using data in various forms, whether it's internal data, whether it's external data, all kinds of data for understanding and prediction of your customers' behavior. So most traditional application of analytics that you will see even today are in these two domains. This is where we started, but that's not where we stopped. It's a journey, and the journey started with that. Okay. So for example, in the marketing, we like to predict who is going to buy our product. In marketing, or if you work in telecom industry, this term you have heard, churn. Who is going to churn? When we have contract with telephone companies, cell phone, internet providers, all of those, who is going to churn and who is going to renew? We're also very interested in predicting not what you will buy, but what you will buy next, so we can promote it. We can promote it correctly. On the finance side, we are primarily on risk prediction. We want to know what is the risk, and risk can only be predicted if I have a prediction model. So again, it goes back into analytics. Whether you are a bank or you are a financing company, you are dealing with financial assets. There is an inherent risk associated with what you're doing. So the question is to quantify that risk using two things. One is the probability of things going wrong, and if things go wrong, how much would things go wrong? You bring those two together, you have the fundamental definition of risk, but understand both of them requires data, both of them require predictive model. That's what was the core of the analytics. Now, where are we now? Well, guess what? It doesn't really matter which organization or which function of the organization you work for. I've got news for you. And that news is you will need analytics. So human resources. Who would think human resources. You know, one of the big things today in human resources is HR analytics. That's a name you will hear if you are in human resources. See, human resources people figured out that, oh my God, these marketing people are, they're doing all this predictive modeling. Why can't we take that model? And why can't we predict who is going to join our company of all these people that we are interviewing? Can we do some shortlisting? Or more importantly, can we predict, which person is likely to leave? So maybe we can take care of him. Or maybe can we even chart and predict what's the best type of training I can provide to this person so that person reaches his or her maximum potential? You see, my friend, it's just what you just have to think. You just have to think about how to apply this and what kind. Of course, it cannot be done without data, but you have this data. This is internal to every company. If you maintain the records, you know this. So it's possible, right? Manufacturing, production, and operation. Now, to be honest, we have done this. Yes, it's under the name of what we call SQC. For any industrial engineer out there or any process engineer out there, you know what I'm talking about. It's statistical quality control. We used to look at charts, the 3 Sigma and 6 Sigma charts, okay? But the charts were just for alerting something if the process is going out of whack. The way now we do it is saying, okay, all these predictive models have been built. Why can't I use those models to predict what's the lifespan of my machine? Just like in marketing, we predict what is the lifespan of a customer. Why can't I predict how long before a machine breakdown so I can optimize and do the maintenance a few days before it goes down instead of doing maintenance every day? You see, it's a model. But for that, we need data. Of course, there is data. So data is available. It's a question of, can we get those data and can we build those models? So it's being used in manufacturing. Of course, it's being used in R&D, IT, information technology. Because IT, at the end of the day, is a service provider. You want to know before something breaks down, before something happens, when it's going to happen, so you can deploy your resources correctly. IT, at the end of the day, is also allocation of resources properly. And you have to understand where things should be allocated to give the best service. R&D, very tough. R&D has always been tough because when we look at R&D, we make investment that may not bear fruit for 3, 4, 5 years into the future. But if we have looked at past data, why can't we look at multiple R&D projects and score them, predict which one has the best chance of success by looking at the past data, and then use those models to look at my current portfolio of R&D that I'm looking at and score them and figure out, okay, maybe this has a better chance than this, and so on. Same thing with service. Same thing with service. So my point to this is, yes, it may have started with marketing. Yes, it may have started with finance. But today, no part of the organization, doesn't matter which organization you are, which part of the organization you work on, every part of that organization would be touched by the power of analytics and data. Now, as things have changed, one of the things I want you to understand, I'll tell you, I've said this at the beginning, that you have to be open to changes. In the world of analytics, we have to be open to changes all the time. Just to show you, give you an example that I practice what I preach. When I first started this, teaching in analytics, it was not yesterday, not 5 years ago, not 10 years ago. If I go back on my time scale, this is in 2004. That's about 17 years ago. There was no word analytics in that popular press at that point in time. That's when we started. So 2004, started this as a data mining certificate program. And then what you will notice over time, we changed. We added new stuff, just like what businesses do. At the university level, we do the same thing, particularly if you're in this world of analytics. So we started with a data mining certificate, then we moved this to online. Then we added a marketing analytics certificate. Then we moved the marketing analytics certificate to online. Then we started a data science option and a business analytics degree program, and then a graduate certificate in healthcare analytics. And ultimately, today we have a degree, one master's degree, multiple graduate certificate, and these are some of the KPIs of our program. My point to this, again, for you, for every potential student of analytics out there, is that life, just because you learn something, your learning doesn't stop once you get the degree. You have to continuously innovate yourself, reinvent yourself, and learn. That's the message that I want to take forward. But that's it. Let's talk about some of the key challenges in the business world. We see this in the business world all the time. Okay. The key challenges are underestimating the hard work of data wrangling. I'm showing you a picture of an iceberg, and I'm showing you the picture. I'm making the bottom part visible. Most of us don't get to see the bottom part. You know, the top part is what everybody gets to see. That's about 1/10 of the iceberg. In the world of analytics, corporate managers they are only interested in this top part. They often underestimate the hard work that's needed in cleaning the data, in massaging the data, in pulling data together from multiple sources. Believe me, no company I've worked with has clean data. Clean data doesn't exist. It doesn't exist. In the real world, the data are unclean. The data are scattered over multiple different databases. The data don't match all the time, and they need to be pulled together. They need to be massaged. They need to be put in the right form before analytics can be done. And that's the part people underestimate, because that's about 80 to 90% of the work, just like in a case of an iceberg. That's one major challenge. Okay, we're getting better. You know where we are better? When you work in the world of companies that have come on board maybe in last 5 years or 10 years even, but primarily in the digital space. Why? Because they started with a clean slate. Most companies I work for, most companies you will work for, have got some legacy systems, and those legacy systems have to work with the new systems, and that's where some of the problem comes in pulling data. The second key challenge that I think you ought to think about, and this is again from a management perspective, okay, is having the right tools. So I'm showing you, for those of you who may not know this. This is a very traditional toolbox, which is so nicely organized. You see how nicely organized this is? You know, everything is in its place. Everything fits together. They work so beautifully. So, got news for you. You come to the world of analytics, you're not going to have a single toolbox. You will have multiple tools, multiple toolboxes that don't always mix and match together, and you'll have to figure this out. So what do we want? I mean, we want something that works at the enterprise level. We want something that can do all of these things, but it's tough to find a single product to do all this. And even if you find, and there are single products that does all of this, but even if you find it, chances are your employees will say, you know what? Okay, that's great, but I don't really like that software. I want to use this. And someone else will say, I don't want to like that. I want to use this. You want to empower your employees. You want them to be the best they can be. So you have to put together a system that lets people play with multiple tools, not one set of tools. But at the same time, you have to take into account that all of these new tools, that they can actually play with your legacy applications, because otherwise you have started a business 40 years ago, 30 years ago, you have some legacy systems that are producing data. If we can't integrate that with the new tools that we are using, then we are in trouble. We're in trouble. But things have come a long way from what it used to be, but these two challenges still remain. And there is a third big challenge that I'm going to address in just a minute. But let me turn this around a little bit and talk about, I know there are university folks here and industry. One of the other messages that I want to send to everybody is that we can't do this alone. We meaning as university. We can't do this alone. And you cannot, if you are representing a company, you can't do this alone. You need us, we need you to make and train the best analysts for future, for you. So, university and industry live in a symbiotic exchange relationship. So here are some of the things typically industry wants from university. They want talent pipeline. They want alternative way of looking at things. They want to engage. So what kind of skills do they want? I'll show you, promise you, I won't make you read this slide or not my paper, okay? But it is one of my papers. We looked at about 600,000 job posting on LinkedIn, and we analyzed those. Yes, 600,000 plus. Of course, we analyzed this using analytics and machine learning. And what we're trying to find out from there is what are the really big skills that everybody is looking for. What you will see is they want communication, interpersonal skill. They want managerial skill. They want database skills, modeling, analysis, business domain tools. All kinds of skills are being asked for. But the most important is communication and interpersonal. Now, this is LinkedIn from US, okay? The jobs are only analytics jobs. In the analytics job, it's never really about just modeling. What this tells me is what really matters is, yes, you have to build model, you have to write some codes, but at the end of the day, if you can't communicate it, if you cannot convince other people, if you don't have those, then it don't work, which is why what Nile University is doing by putting that analytics within the MBA program makes sense. Makes sense because you need those other skills as well. Now, as far as modeling goes, it's a smorgasbord of tools and techniques that companies look for. Almost anything under the sun that you can think about has been mentioned in those 600,000 jobs that we analyzed. Okay, do we cover all of these in a class? Well, it depends. It depends on how deep you want to go. My thought on this is, again, depends on what your level of interest and what your level of preparation is before you join a program. We have reached a point today that we can teach you analytics without doing too much mathematics. If you asked me 10 years ago, I would have said, no, if you don't know matrix algebra, I can't teach you analytics. But software has come such a long way. They have made it so much easier that if we can get through the basics and we can teach you how to do some of this, maybe not the math, but how to apply it. But then at the end of the day, if you think about it, where I started, I said, at the end of the day, what's the definition of analytics? It's how it adds value to the organization. What is the point of building a model if I can't explain the model or if that model is not used by anybody? So my point to this is you need broad-based education. You need, of course, you need modeling, but you also need beyond modeling. So this is the third key challenge. You know, I hear from companies, I talk to companies all the time in the US, and I hear from some of my friends in the companies, a HR director or a VP or somebody, they call me on the phone, say, hey, Professor Tchakaporty, how are you doing? I said, I'm doing great. I've got a need for hiring an analyst. Do you have a student that you can recommend? I said, sure. How many do you want? And I said, just one, but I've got some needs. I said, okay, fair enough. Go ahead. Tell me, what do you need? He says, you know, I need somebody who is good in modeling. So no problem. No problem. I can get you that. You know, I need somebody who is also good in explaining those things. Okay, I can do that. I also need somebody who is very good in coding, so they can pull data from everywhere. Okay, I can do that. And I also need somebody who knows how to do teamwork. Okay, this is getting a small set from my 100+ students, okay? And then you know, I need somebody who can do storytelling. I need somebody who has a blah, blah. And oh, by the way, I don't want to pay more than $50,000. And I said, okay, you're looking for me, a completely multiple personality disorder, who didn't know what he was doing in life, and you want to pay me $50,000? First of all, you're not going to get me. There's no such thing that exists. Second, you're not going to get me for $50,000, my friend. But what's my point? My point is this. Companies today are asking for so many different things that a single class or a single training is not enough, not enough. And companies need to understand that they need to create teams. Companies have some of these in their own workplace. They just have to develop them. They just have to give them the new tools, the new training to become that unicorn. But you can't find that easily. That's where the partnership comes in between academia and university. The way this really works is universities have to work with industry, and industry have to work with university to develop this, So, you know, as universities, we want certain things from industry. We want projects, for example. We want real company projects. That's experiential learning, because I can teach them technique, theory, blah, blah, blah. But at the end of the day, if you haven't got your hands dirty with real project, you really don't understand. Research products, sure, we would like to publish and would like to collaborate with industry, and we need data. Maybe hidden data, maybe data which is masked. We want industries to be part of our advisory board. And then, of course, universities are always hurting for money. So donation, we'll take those too. So just to put this into perspective, how do we engage with companies in USA at Oklahoma State? Okay. At Oklahoma State, we work with companies to do internship, because internship is a big part of this, that experiential learning. We work with universities, as a university, we work with companies to give us funding for research. And those research provide assistantship. And at the end of the day, we work with the company data and we give the product, or whatever the deliverables are, back to the company. So the company gets something, they train a student who is already now used to the company's culture, data, so they can get the pipeline of talent down the road who is already trained in that domain. We do company-sponsored projects done for free by a group of students. We have corporate advisory board. We run a one-day conference, just like the way you are doing right now as a public lecture with me. We would run a one-day conference, a full-day conference on analytics every year. We'll invite companies, we'll invite our advisory board, and we'll put our students there, and we bring them together to spend a day with us to come and listen to speakers from industry. And then, of course, we would do placements. So before I go to my next slide, I want to do a quick check. Dr. Hassan or Dr. Mustafa, would you tell me how we're doing on time? How are things going? Do we have time for taking through at least one case study? And
yes, please. Yes, Gautam, 10 more minutes or 15 is fine.
Okay, I'll finish it in 10. So I want to leave some time for Q&A, so that way.
Excellent.
Okay, so wonderful. So I'm going to give you a case study, and I'll take you through this case study. One of them, I'll take the financial industry case study. But before I jump into that, I need to tell you something that you probably know, but haven't thought through it that much, okay? I want you to understand the difference between what we call structured and unstructured data. Structured and unstructured data. And then after that, I will take you through the case study, and then I'll summarize with some lessons learned that I have learned over the years doing projects, and then we'll open it up for Q&A. So, structured versus unstructured data. Most of us, particularly people like me who don't have any hair on their head, who were born and brought up long time ago, fairly old. Yeah, no, it's not that old, but it's okay. But we have grown up in this world of what we call numeric data, which is structured. They come in a spreadsheet. Most of us understand, given a spreadsheet today, most of us know, how to do mean, average, standard deviation, maybe even some graphing and some modeling. Okay, we have grown up in that world. That is the structured data world. But then suddenly something happened. And what happened is unstructured data came onto us. So here is an example of an unstructured data. Look at this data. This is data. How the heck do I analyze it? I don't know. I don't know how to go from here. I know what to do here. What do I do with this? Don't know. Or for that matter, what do I do with this? All the telephone calls and the IVR, the interactive voice response data that are being generated. That's voice. And then welcome to the world of YouTube. Now we have video data. People are posting people don't even write anymore. They don't even talk. They post on Instagram. So we have to analyze images to figure out what they're thinking about. So you see, my friend, what's going on in that world is we started in this world, and the world has changed on us. So one challenge that it creates for us is on the data side. How do we, because I have some structured data, how do I take this unstructured data, however I do it, I got to combine them together to build a model. That's a big challenge. So the case study that I'll present to you right now is a financial industry case study that I was involved in. And again, I can't give you the name of the company or anything like that, but give you an essence of what that case study was, where we did exactly what I'm just pointing out. So this company, it's a financial industry case study, a few billion-dollar company at that point. Now it's a much bigger company, but when I worked with them, there were like, I can't remember, $3 or $4 billion in US at that point. Today, it's more than $10 billion company. But this company's business line, so again, you have to understand the context. This company specializes in debt collection from delinquent customer. Debt collection from delinquent customer. What does that mean? That means there are people who taken a loan from a bank for maybe buying a car, or maybe they have taken a loan for whatever, some reason they can't pay back, or they have charged up too much on their credit card and they can't pay back, and they declare that we can't pay and we're delinquent or not paying. What those companies, what the banks and the credit cards and the others do, they try to get the money out for a while, and then at some point they just write it off. They say, okay, it's too much of a pain, we can't get the money out, we're going to sell those accounts to this particular company, this particular financial industry, who will buy them on 10 cents on the dollar, meaning for $1 worth, they'll pay only 10 cents. Then this company will go after trying to get money from those delinquent customers. So the business challenge that they had, they had a prediction model. Of course, they had a prediction model to predict, what is the propensity, what is the chance that a delinquent customer will pay based on transaction. Transaction means that customer's transactions over time with their original banking or credit card industry, transaction data, and third-party data. Third-party data is when we bring in data from outside to append with the internal data to get a more 360-degree view of the customer. So, for example, we will bring in data from all kinds of sources. US government has census data. We can bring those in. There are multiple companies that sell data on consumers' credit card usage, consumers, even driving pattern. We can bring all of those data and we can create a better profile of the customer. So this company has been using that. The question they asked us when we got involved with this is, can this prediction model be improved by analyzing texts from agent-customer interaction? Because at the end of the day, the agent is calling the customer every day saying, hey, you have to pay, otherwise we are coming after you, we're going to sue you, blah, 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 all kinds of things, right? So the customer is saying something back. So these are all being captured by law and by US law. When a company calls for debt collection, they have to have the whole thing recorded. So therefore, we have the recording. So the first pain is converting that recording into text. So we use software to convert recording into text. And today that has become much better. When I was working on this, the accuracy was about 65–70% in the best of the breed at that time. Today, that accuracy comes to 85–90% in converting from what we hear on the phone to text. And the question was, if we can bring in this data, could we improve the model? Because if you improve the model, they get more money. At the end of the day, that's what the financial company is looking for. So the current system is simply, they're buying delinquent customers. It's going into their collection system. The agents are calling the customers. The company is also sending them letters, and then hopefully, they're paying. Not all of them pays, and the scoring engine is the model that they have. That was based on their data that they have and the third-party data. Here is the new model. What's the difference? The difference is now we are capturing the voice data and we are converting into text. And then we are going to analyze those and pull that back to see if the scoring can be improved. If the scoring improves, then company's bottom line improves. If the bottom line improves, then they're happy. So I'm showing you a very simplified version of a model. We tried a lot of different models. This is just a simplified version of a model using a product called SaaS Enterprise Miner. Again, that's because that's what we used at that point in time. And this graph may be hard to take in, but let me explain this as quickly as I can. If you look at the line at the sort of the diagonal line, which is green, is the baseline. Baseline means it sort of gives you how good the model is, if you do no modeling. It's baseline. Then the red line is their current model. And the blue line is when we added the text analytics. Now, if you look at it, you will see the blue line is above the red line and the red line is above the green line. That means the blue line is better than the red line. What's my point? My point is by pulling in that new source of data, the speech analytics, we improve the company's scoring model, which in turn improves their bottom line and they're happy. So value is an increase in their collection. So lesson learned in my life with multiple projects. There is no easy button. Okay, there is no easy button. What's needed for analytics project is you need enterprise level software. You do need time to play and learn. And then you need domain experts and trained text analytics. So my suggestion is, if you're ever going to do something, start with your internal data first, then bring it. People get carried away thinking, oh, I'll get data from Facebook, I'll get data from Twitter, I'll get data from Instagram. Wait, you have plenty of your internal data is your first source. Start with the internal data for the low-hanging fruit. For the external data, just set up a system so you can monitor and track that data. As you get more adept, then you can bring in those external data. So I go back to what I said. Analytics is a journey. I urge you to start that journey, regardless of which company you work for, regardless of your silo in the company that you're working for, regardless of your background. Take the step. Take the step on starting that journey. In the long run, I think all of us have to use analytics. And I hope you start this with Nile University's MBA program, as was mentioned. And you know what? Perhaps I will see some of you when I'm down there. I'm looking forward to. I've never been to Egypt. I'm looking forward to my visit, and I thank Dr. Hassan and everybody else for inviting me. So I'll open this up for Q&A. So I'm happy to take Q&A. Dr. Hassan.
Thank you very much. Thank you very much, Gautam. It's been very enlightening and entertaining at the same time. I do have already some question being posted on the chat line. So let me take it one by one here. There's a question from Noha Bulkhair, and she said, if I have the same data each period, how do I do untraditional analysis? How to ensure that the provided analysis is to the management expectation? How to ensure that I covered everything can be analyzed? I think it's a little bit it's like asking about how do I catch big fish from the sea. But I'll take the other two questions, and then we'll have Gautam answer three people at a time. I think Dr. Muhammad is saying that data scientists spend 70% of their time for wrangling data. If any noise or inconsistency in the data, the model accuracy is not acceptable. Traditional statistical model is better, or machine learning model, for it depends on data itself. Question number 3, can we say BA is a DSS or an expert system? This is Ibrahim Sultan, our finance professor. Finally, George Fahmy, this is our economist, says that is the difference between predictive and prescriptive analytics based on the amount of value added to the organization or any other criteria. How close is business analytics to managerial economics? Since ME combines managerial economic combined application of economic theory, managerial practice in the industry, and the later can't be done without analytical data and the statistics. So I'll let you take these couple of questions and then we'll go on.
Okay, so let me start with the very first one. That's from Noah. I know the question is very long-winded. I think, Noah, what you're looking for is you can't figure out what analysis to do unless you know what is important to your management. At the end of the day, one of the hardest challenge that you will ever have is getting things out of decision makers what they really want. Because without that, whatever you produce may not work out. may not work out. So there is no easy solution to the problem that you said. If you have, how do I make sure that they're happy? Well, the way you make sure they're happy is first figuring out what makes them happy. What is it? So one of the things that we do is when we sit down for doing project with companies, we ask the question that, okay, if everything goes right, at the end of the day, what is the product look like? What do you want from us, from deliverable? So you have to put yourself in a consultant mindset. The consultants will always clarify, ask, rephrase, reframe questions. So this is what you mean? Is this what the output looks like? Is this what the dashboard? Is this what the outcome of the model? What are you going to do with this model? Now, it's difficult when you are an employee and you try to do this. It's easier for a consultant, but really that's what you have to do to get some idea about that. Okay, that was the first question. Tell me the second one, just quick, Hassan, I forgot what the...
Yeah, the second one is something about the inconsistency of the data if there is noise. And
Okay.
if the traditional statistical model is better or the machine learning model.
So in my view of the world, you can't do one. You have to do both. Without learning traditional statistical model, you can't do machine learning model. Now, which is better or which is worse, that depends on the degree of noise. That depends on what is the, what is it that you are looking for? So for example, if you are asking more from an explanation that we have to explain the model, I cannot explain what comes out of a deep neural net. Not possible. Nobody in the world can explain what comes out of a neural net, let alone deep neural net. So if you are looking for, what are you looking for? Are you looking for predictions? And you don't care how the predictions come out, as long as the predictions are good, you're okay. Machine learning almost always will beat traditional statistics by a little bit. Now, I'm going to be very clear. I have taken multiple data sets using statistical model as well as machine learning model. The difference often is very little. Very little. If you give me enough time to build the model, if you give me enough time to build a good logistic regression model, and if you take an expert in machine learning and give them exactly the same data set, and give me the time to build the logistic regression model, my model will not do any worse, at most 0.5 percentage point. Because at the end of the day, the data is the key to this. What is the information contained in the data? You can only massage it in so many ways, my friend. But when you allow me to bring in new data, I change the game completely at that point in time. So okay. Yes, noise affects both statistical model, we call them random error, as well as machine learning. The advantage of machine learning is because we use the calibration validation method to optimize model, it might be slightly better picking out more robust model. But even in the statistical domain today, we have fantastic, good old regression. Look at quantile regression, a beautiful method, if you really have that much of noise in the data. So there are lots of possibilities, lots of possibilities.
Okay, number 3, Ibrahim Sultan saying is a BA business analytic is a DSS, I assume, the decision support system.
Support system.
Yeah.
Sure. Sure. I mean, look, we've got to sell books. Okay, I have this saying that I say, if you follow the cash, all the BS goes away. If you follow the cash, we have to come up with new terms. Fundamentally is not that different. What has changed? So let's talk about what has changed. What has changed is the amount of the data.
Yes.
The variety of the data. Today we have text and video, audio, blah, blah, blah. We didn't have those as much before. And what has changed is the velocity at which the data is coming at us.
And I may add the superiority now of the computing system.
And of course.
So that's why business analytics came to the surface. As Professor Tchakapurty mentioned, 2-factor. One of them is the data in terms of magnitude and variety, and the other one is the super computing system that exists right now. So you have what we call the new oil. The new oil is
exactly.
That's it. George is asking about whether any difference between the business analytic and the managerial economics, I think. How close business analytics to managerial economics?
I think there is a fair degree of overlap. I mean, because if we are solving similar problems and we're trying to do it using statistical model, surely that's very, there are areas of overlap. Look, as I said, business analytics is not one thing. Business analytics is solving a business problem using any data tool technology that's out there, whether it's an economics problem, whether it's a financial problem, whether it's a marketing problem. To me, it doesn't really matter. To me, business analytics is a broad umbrella term that basically says, you know, we're going to use any data tool technology that's out there to solve a business problem in any domain. Now, does that mean there is overlap? Of course there is. Of course there is. We can say even it overlaps with marketing and marketing research, of course. With financial risk management, of course.
Okay, I think Karim is asking whether the business analytics and data science are related to the Lean Six Sigma, which is
of course. So Lean Six Sigma, my friend, is pure statistical model. But the thought process of DMAC, you know, if you know Six Sigma, if you've gone through the DMAC, the thought process of DMAC is absolutely same in the way we deal with business analytics project. The core issues of statistical modeling is the same, but it's gone far beyond that point.
Excellent. If we have any question, please raise a hand, or you can just open the mic and see if we can hear you. I think it's very important that we have Gautam around for the next 5 minutes to let you know that this is just whetting your appetite for business analytics. He will be coming to teach the first course in October at 9 University MBA program. And I'm sure there will be very useful stories to tell. Gautam known to be a great storyteller. That's what he is known for. And right now, I think business analytics is a new field, a new era, and we are really scratching the surface. The question that's been asked in the very beginning about I have traditional data, how do I do untraditional analysis? I think this is very interesting because it depends, as Gautam mentioned, on your objective. What is your objective? If your objective is to answer a certain question, ask your manager, ask your CAO to let you what is the new question that needs to be answered. And now, because of the huge data that we have and the many variety of ways to analyze it, we can answer new questions, and we can give much more detailed and accurate prediction than before. I think this is what really distinguishes the business analytics, that we are able now to give more accurate prediction of a lot of factors, things that we have never expected that we are able to predict. Right now, we can do that with this huge mine of data, and the ways that people like Gautam help to basically put together to analyze the data. If we have no question, let me thank Professor Tshakaporty really very much. We have enjoyed your presentation. And on behalf of 9 University, I really raise my chapeau for you for this very nice, simple, but rather deep presentation. Thank you very much. Thank you for everybody. And I'll see you in the next public lecture of 9 University. Thank you.
Bye.
Bye-bye.